So I noticed the other time on the other stream when I was doing a review of the other stream. I noticed that my audio is incredibly low on that machine, and so cool. So what would I like to do? What would I like to do? I wonder. Can I play something so that I know? Oh, it's playing. Okay. I just need to move to my headphones from my computer. Much clearer now. My audio should be much clearer now. I'm using my headphones, so yeah. And I'll try and get a Mac microphone soon so that I can speak much clearer on these issues for next time. But other than that, it's been amazing. It's quite amazing to have you guys here. And I think since it's already officially time, so then I'll just run on YouTube and check if my stream's running. To have you guys here. Cool. And my stream is running. Sounds like my audio is quite clear. Let's do today. Cool. Just closing my emails, just opening my notes so that we have everything we need. New window here. So GCC guitar, but for anyone who cares, I use GCC as my username on YouTube because this persona of me is very inundated with Poseidon, or if you want to say it the right Greek way, Poseidon. I like Poseidon, and one of Poseidon's nicknames was Gaia. It's something to do with Gaia and under the Gaia and whatever, and that's why I use Gaia for anyone who's interested. So let's talk about what we're doing today, or what we want to talk about today. So let's explore some stuff. What I wanted to do today is so I wrote a blog. I wrote a blog post a couple of days ago here, and it was basically like an explanation of what RTOSs are. And I'm probably going to do this in a couple of weeks with a bigger platform at DevEd, where I spend quite a lot of time. But that explanation is going to be much more succinct, and it's going to be much more applicable to like watching at a very. It's going to be very sieved, and it won't have all this extraneous details. So later we'll do that. But for today, I just want to do some sort of a primer on RTOSs and FreeRTOS in particular, and yeah, let's do a primer on FreeRTOS in particular, and then we can kind of build up on this stuff and realize what we want to do. So I'm gonna assume you're watching this video, you know what an RTOS is. If you don't know what an RTOS is, I'll give you a very quick, simple explanation. An RTOS is a real-time operating system, and a real-time operating system is something you use to write real-time applications. Real-time applications are applications that have very time-specific deadlines, and if these time-specific deadlines are broken, things could go catastrophically wrong. That's what a real-time application is. So that fixes it all for us. What a real-time application is, what an RTOS is, So now we can actually talk about FreeRTOS. FreeRTOS is a kernel, an operating system kernel, or a real-time operating system kernel that is distributed by Amazon or AWS. And it was originally developed something, I think it's somewhere like since 2003 or something of sort. Early 2000s is a free and open source project that was started by Richard Barry. And then some, I think in the early 2010s, so something like 2012, 2013, 16 there, I'm not so sure. The stewardship of FreeRTOS was taken over by Amazon Web Services. And Richard Barry joined Amazon Web Services, and I think up to date he's working on the FreeRTOS kernel. Cool. So that's what FreeRTOS is. It's a real-time operating system kernel that we can use to implement real-time applications. Okay, cool. So now let's dive into the specifics of what we want to know about FreeRTOS. So FreeRTOS is it's distributed as a set of C source files. So if we go here and we go to, we can either look at download FreeRTOS, which I think we can just check out in GitHub. Let's look at the GitHub. It's easy to see. Sorry, my screen is dying if you see that. So this is the FreeRTOS distribution repo. And whenever you download FreeRTOS, whenever you do download FreeRTOS from here, this is basically what you will get. Here is my local download. So I will go to, I think, documents, and I think embedded, and I think FreeRTOS, and I'll have FreeRTOS in here. And I'll have the same folder structure. You can see I'll have FreeRTOS, FreeRTOS Plus, I'll have tools, and this other conglomeration of files. Cool. So that's what you get as the distribution. So basically, what we do want to understand is what is this bunch of code that we have gotten, this bunch of code that we have downloaded, and how do we use it? So this bunch of code that we have downloaded, and how do we use it? Okay, I'll open that, try and open that, and see if we can, yeah. So what's this bunch of code that we have downloaded, and now we can use it? Cool, amazing. So let's explore some few basic lower level information points that will make FreeRTOS quite easy for you kind of going on. So FreeRTOS itself is distributed as a set of C source files that serve as libraries. Okay, so you have like a queue library, you have like a list library, you have like a timer library, you have like a message queue library, and you see if you usually make embedded applications, you know, like if you have like a timer and you could have a delayable timer that you can use across your application. Like the other day on one of my former streams, I was implementing I was implementing a time-based delay that could be used across the application. The same one I did add a critical section to in a couple of videos back. So the timer, the timer module, the timer code. If I look here, and then if I go into source, and we'll see if we list this. Let's go here. If we list here, we will see there's a timers.c, and this is the timer. This is say the timer. So there's timers, there's tasks, there's a stream buffer, there's a queue, there's a list, there's an event group, there's a coroutine. Okay. So there's those sources that you're given to use in your RTOS implementation, or in your application that uses FreeRTOS as a base or as the kernel for its operating system. So FreeRTOS is ideal for deeply embedded microcontroller or small microprocessor applications. It has features that cater for both hard and soft real-time applications. Hard real-time applications being applications where any sort of deadline message slippage is considered catastrophic. And soft real-time applications, meaning applications where, yes, they do have real-time requirements, things have to be done on time, but if something doesn't happen on time, nothing breaks. So I usually, the most common example here is usually something like an airbag system is a hard real-time application. Like you have to deploy the airbag at the correct time, as the car is crashing. You can't deploy it before, because that would could cause more problems. You would randomly deploy the airbag whenever someone's just driving, and you can't deploy it after the crash has happened, because you could further whatever, exasperate the injuries of the driver or the passenger of the vehicle whose airbags you're controlling. So there's a very hard deadline at which point that action should be taken. Your CPU should not be doing other things. Your CPU should not be worried about braking and stuff. When the time for airbags should be deployed then, and not a second later, not a second earlier. Cool. So that's a hard um, real-time application. And then the other thing about FreeRTOS is it can be used with quite a number of architectures and compilers. So something like 23 compilers can use FreeRTOS, and 43 processor architectures are supported. So this is 23 compilers, each supporting 43 processor architectures. So that's we're in the close of, I think it's something like 900 or something. I don't know. I think so. So if we do 23 times 43, I think we have, yeah, 989 supported processor compiler combinations. Each supported processor compiler combination is called a FreeRTOS port. And whenever you are modifying FreeRTOS to run on your hardware with the compiler that you're using, you're doing what is referred to as porting FreeRTOS. Remember this term because it will come up a lot, and it's kind of small terms that like this that cause confusions later down the line. So if you remember terms like this and you're in a group and the group is just talking about FreeRTOS ports, you know what they're talking about. You're comfortable with what they're talking about. You can handle what they're talking about. Cool. So we have a FreeRTOS port. We know what a port is, and we know how, I guess, ports work, because you basically get some source files that, as I mentioned, so you get some source files, and some of these source files are common for every port, and then some of these source files are specific to your port. So once you collect the right combination of source files for your port and the ones that are used in every port, then you have a FreeRTOS port, if that makes any sense. You have a version of FreeRTOS that will run with your compiler and your architecture. Okay, cool. So let's now explore some of the files that we get with FreeRTOS that are pretty important. And understanding these files will make it so that you can, how best to explain? Understanding these files will make it so that you can participate in conversations about FreeRTOS, and you can easily decipher what is a FreeRTOS file or what is FreeRTOS code and what is application specific code whenever you get yourself into some you've joined a team, they're using FreeRTOS on a new compiler on a new architecture. Which files are FreeRTOS and which sources are FreeRTOS and which sources are application. Okay, so understanding what is going to give you quite a leg up in getting things going and getting things achieved. So FreeRTOS has a number of files that are common to every port. The first file is the FreeRTOS config.h. This is a configuration file, and it contains specifics. It contains like let's look at one from the let's look at one for a demo that we are quite familiar with. So I'll look at the Cortex M4 or M7 because I'm familiar with those. So let's look at Cortex M4F, and then I'll see if there's a STM32 somewhere here. If there's indeed an STM32 and an yeah, cool. Yeah, good. Cortex F407, F4M4 with the STM32F407. This is basically the board I use. This is my native board. I'm very comfortable on this board. Cool. So in here we have a FreeRTOS config.h, and this FreeRTOS config.h, it defines macros that we want to use in our files. So this we'll explore these ones later when we're exploring doing things with FreeRTOS. Right now we are exploring getting started to do things with FreeRTOS. So this is one of the files that you get. And this file is going to be specific for each application. It's not like for each port or for each or common through all the ports. You're going to most of the time you'll come here and choose one of the supported demos, some supported compiler, architecture demo. And from this architecture demo, you'll get the config.h, and you can use that config.h to configure. Go figure. I don't know what I'm so I did. Yo, that was not a good joke, but I'm still laughing. So we'll see. I'm gonna open chat so that if anyone wants to message me, they can message me. And we are live. Amazing. Cool. So we know the first thing, FreeRTOS config, common in all ports. Cool. And then we have a couple of common, these are all the sources that will appear in your port, and this is how like you need to use. Okay, cool. So task.c, this tasks.c, provides task management, handles priorities and delays and timeouts for tasks. Okay, and then we have a queue, implements a queue for you when you're doing real-time applications. You'll want to use queues for message passing inside of a sort, and this will implement queues, and then it will implement like things for blocking and non-blocking, transmit or receive, and whichever way. Okay. And then you have lists.c, and this implements doubly linked lists for task management and event lists. So used for maintaining state of tasks and messaging between tasks. Okay. And then we have timers.c, which implements software timers. And software timers would be something like here. So if you've gone reasonably deep to implement your own application, you will find yourself, if you implement a very interrupt heavy application, you'll find yourself having to implement a timer for delays. If you're using interrupts, you want non-blocking delays. That's why you're using interrupts. So you don't want to block and wait for something. You want to use non-blocking delays. And basically what happens is, so you want non-blocking delays, you'll end up building a timer, a software timer such as the one I'm showing you right now. And this is just a generic timer, which basically you can initialize your timer, and then you can start a timer. You can check whether a timer is elapsed, and then in here you have a stick handler, and you have timer.update, and in timer.update I'm just delaying, decrementing all my delays in all my timers. Okay, cool. Perfect. So timers does some of the sort. And then you have event group. Event groups, this gives you primitives to do synchronization between multiple events. So let's say you have like an application that uses 5 sensors, or let's make it simple. Let's say 3 sensors. And then you have an event group where you want all sensors to collect data before main or before whatever is going to process it processes it. So you'll make an event group and this event group will wait for all 3 sensors to collect data. And then once these 3 sensors have collected data, it will hand over all this data that has been collected to somewhere else. And once that data is handed over, it can be processed as deemed fit. Event groups, if you've done any sort of streaming and such, event groups give you primitives for things like back pressure, things like wait until. Back pressure is basically wait until, or wait, I'm not done, not yet. Scenarios that require those terms, not yet, wait until. This is scenarios that are this is stuff you will find in streaming a lot, and in the FreeRTOS source, event groups provide you with this. Okay, cool. And then you have it's usually heap 1 or 2 or 3 all the way to 5, and this usually provides memory management schemes for dynamic memory. The most common one so far is heap 4. It's popular. It's popular because of it's simple, and it's because of its best fit algorithm. Cool. You can look up those terms and find out. And then we have a port.c, and this is a port layer for the specific architecture that we're running. So say we're running as STM32M4 like this. Uh, this is we would the port here would be an ARM Core M4 or something, and if we're running an NRF 528, do I remember what they run? I think it's also Core M4 NRF 52840. I am willing to bet this is a Core M4. Core M4, Core M4. Yep, Cortex M4. Yeah, so I'm very comfortable at Cortex M4. It's unfortunately I stay there too much. So that's a PIC 16. So that's gonna be a different architecture. It's not gonna be ARM whatever. Um, that's a PIC 16. So there's that, and then we have the current dev boards, dev heads demo board that we are reviewing, and that's NXP MRT 1060, and that's running on a Cortex M7, and that's the example I have. So port.c is going to run according to the different architectures that your processors are running, and from there you have like defined what would I call them? Defined low-level specifics, machine specific stuff like your primitives for context switching, interrupt handling, things like pending interrupts and such of the sort, pending timers, pending tasks and things. This is all in port.c. So these sources that we've looked at now, these sources collectively provide the core functionality of FreeRTOS. These sources that we've just described, plus, of course, like there's quite an amount of, I mean, you don't have to be, so we have this, plus the files in here as well, but they're like, these are includes of includes and such, and but they're all used by the files that we just talked about. So these files collectively that we've talked about, they form the distribution of FreeRTOS. Each of these files will focus on a specific aspect of the real-time operating system and making FreeRTOS both modular and efficient. I think the only file that is always needed, or the only source that is always needed, if I'm not wrong, is the tasks source. That's always needed in all the implementation. And then all the other files are not necessarily needed, and you'll add them as you need them for your application. Okay. What does this do? It makes FreeRTOS very modular and very efficient. You can carry only what you want and only use that. You don't have to carry everything for everyone. If you're not using it, you don't need to carry it. You don't need to bring it on. Okay, cool. So let's go. Next part. So when you open a FreeRTOS application, and you start like, um, sorry, I'm gonna try and go back to the M4F again, the STM32, because I'm familiar with the STM32. It could be any STM32, but I want to look at the one I'm familiar with. Okay, cool. So once you start like looking through the code of a FreeRTOS based application, you'll notice conventions that are might be quite different. Like here, you'll have a file that is you see a file that has a lowercase. I mean, you see a macro that has a lowercase uh, name, and then obviously the traditional macro definition, which is an uppercase definition. And then you see things like PRV setup hardware, and PRV check timer callback, and you see things like VReg test one, test two, and you see like vstart led flash, vstart task scheduler. Okay, what am I trying to explain? Functions and variables in FreeRTOS are named using certain conventions. If you understand these conventions that are used in naming functions, variables, and macros in FreeRTOS, it's going to be very easy for you to jump into any existing FreeRTOS application and just start using it. Start maintaining it, start doing whatever you want to do with it. You could all when you start building a FreeRTOS application, if you have this conventions in mind, you'll end up building something, an application that someone else who's familiar with FreeRTOS can come and fix. And in case you're not aware, we live in a software world, hardware as well. I mean, no, but far more software. This is this is what I do with. So, but it's very difficult to grow teams when source is written in like its own way. Okay. But if there's a general way that source is written and you can dive into this source, thinking about the general way that source is written, it gives you a leg up in building your team. You can develop your team very quickly. You can split out modules to be done by people offshore. You can do some stuff by yourself. Yeah, and you can debug code very easily because you can look at symbols and understand what they mean, where they're from very quickly if you maintain this variable, function, and macro naming scheme that we have. So let's before we even dive into the code of this stuff, which is very simple, we're just copying stuff over and changing our compiler to add the stuff in, and then we're done. Like that is adding FreeRTOS. So more of adding FreeRTOS to your project is actually understanding the things that FreeRTOS comes with, and how to use them, and how to look at a project and separate the concerns, like that is FreeRTOS and this is not FreeRTOS. You see, or this is my application and that's FreeRTOS. Bus factor. If your lead developer disappeared tomorrow, would someone else be able to step in and start fixing stuff? Sorry. Okay, cool. So let's look at data types in FreeRTOS. So there's two primary, like at the base of everything, there's two data types that you need to be aware of, and then from there on you can build on to others. So there's a tick type, and tick type is going to be whatever you have put into config tick type into config tick type width in bits. So you can configure the width of the tick type in bits. And usually this is either 16 bits or 32 bits and 64 bits. It's very performant for 8-bit and 16-bit systems for one to use 16-bit configs. However, for 32-bit and 64-bit systems, there's no reason to use a 16-bit configuration. The other factor is it makes it so that you can only use very small blocks of time in 32-bit and 64-bit systems. So it kind of is counterproductive in those systems. So don't use it if you don't need to. Mess with it if you know what you're doing. Base type T, generally the native data type for the architecture, which is also the most efficient data type for this architecture. So it's going to be 16-bit for 8-bit and 16-bit systems, 32-bit for 32-bit systems, 64-bit for 64-bit systems. Okay, cool. So the width of the native data bit. These are the important things really, because it's very easy to skip all of this and then go to the bottom, which is it's a list of 7 things. Most of it you've already done. Like it's download this, copy this here, copy that there. If you go and jump straight into doing this and then you have FreeRTOS, you can easily like you don't know what is what. So it's quite I find it quite better to understand well, and this is a theme that goes through all my engineering and whatever and all my life and all my like understand the thing you're doing well enough before you start trying to do it. And that's why I'm talking about what seems to be arcane things in FreeRTOS, but it's not, because this is the stuff where when I'm exploring a code base, I want to be able to just look at stuff and like make a context map in my head. That's a function. That's a macro. That's coming from here. That's from the timer library. That's from the queue library. I just want to be able to look at stuff and know where they come from, and then that way I can narrow down on very specific parts of code. Usually, I'm reading code, trying to change it so that it can do something different, and then if I have this context, I can quickly understand what I need to change, and then after that, change it from there on. Okay, so let's look at variable names in FreeRTOS. So now that we know why I want to look at them. So there's a few conventions when naming variable. There's variable when naming. Whoa! I just forgot how to speak. There's a few conventions that one needs to follow when naming variables in FreeRTOS. So there exists a number of prefixes, and the prefixes are the ones that are on the screen. So there's C for chars or characters, S for shorts, L for longs or 32 bits, X for the base type system, U for unsigned variables, P for pointer variables, V for void variables. Okay, and then so like the example says, so you can name C letter, that's a char, S short num is a short number, L long num is a long number, X event group. You see, is a 16-bit, 32-bit, 64-bit event group or something. And then I could have an US, which is a U unsigned short number. So I've that uses 2 prefixes, U and an S. You see, this is gonna start becoming prevalent. You will see this over and over in FreeRTOS code. So X, XR, PRV. Let's look at VPAR, X timer, configure SAT. So X semaphore. Let's look for a few more. Let's look for a few more. Something else we haven't seen. ULFPU. You see, so ULFPU. What is UL? It's an unsigned long, isn't it? Looking at the stuff. It's an unsigned long. Okay, cool. So variable names and their prefixes, and then you'll have functions, and functions have their own prefixes. Function names in FreeRTOS are generally prefixed with a return type. So the return type, according to the variable that we talked about in the variable names, and then the file where they're located. So again, let's look at some code. We can look at my blog, but we can also look at some code. So let's see. Let's look at something. Uh, Something like I'm looking for something that's going to be easy to explain on the spot. XAR. No, I don't know. So let's. Okay, cool. V task starts scheduler. So the function name here is start scheduler. Okay, and then it returns a void, and then it's in the file tasks task. Okay. Okay. So let's look at another one. Vstart returns a void, probably in the startup file, and then led flash tasks. Okay, cool. Uh, vpar test. So there's probably going to be test somewhere, and that's where it is. Okay, cool. And then let's look at v application tick hook. So there's a void here, and then it's in the application file, which for us is main. Okay, so that looking at it, so we prefix it with the data type and the file. So here I have I have three examples. So there's v task priority set, which comes from the tasks, and it's a returns a void. X queue receive returns the base type, is in queue, performs a receive. PV timer get timer ID, it's in timer, returns a pointer to a void, which is a function, and then get timer ID is the name of the function. So understanding this makes it so that you can look. Now you're looking at the before you would look at this code and be like, why is V? What's X? Why is it PRV? And once you understand things like this, then you can just read this code like code you understand before, with all this UL and VREG and config making more sense as you go along. You know, so if I look at configure SAT, I know it's a configuration that's in a SAT. I know I can find that in if I go demo. I know if I go demo, if I go here, I know if I go in here and I go for config SAT, see, I'll find it here. It's defined here. Okay, so I'm using this primitives. Apologies, I skipped ahead. So I looked through a macro and I used my naming scheme to find where a macro was. So with macros, it's the same thing as function. They're prefixed with lowercase strings that define where they're from, and then the name of the macro itself in uppercase as usual in C. So port max delay is in port, task enter critical is in tasks, PD true is in project defs. So well, let's see, there's a project defs you see here. So the project defs file here. Just a moment, it's gonna be here. Might be in config as well. I usually don't use is in a board libraries. No. So where is project devs? PRG devs. PRG devs. So I want to do command F PD true. I want to loop it here. So what I'm trying to show is project devs is usually defined in a proj devs devs. Okay, so maybe we don't have that file here. Okay, cool. I see what's happening. cool. So that project does not have that file, but this would usually be found in a project def.c. So that's a file that defines project definitions. And config would usually be in the FreeRTOS config, and task is in task and asset. So that's a basic kind of primer on what to expect when you're going into FreeRTOS. Okay. So now let me let's open a project. Let's open one of the projects that we are quite familiar with. Why? Oh my word, human beings can be so distracted. I don't know why I opened my email. It should definitely be closed. Okay, cool. As you can see. So, um, let me see if I have all the four. Okay, so cool. So let's I just went somewhere to get the stuff I needed. Okay, so let's look at how we need to do this. So the book on FreeRTOS describes this very well. Let's look at official. I want to look at instructions on how to creating a FreeRTOS project. Okay, so look at it. It says, hey, whenever you want to start a FreeRTOS project, please do use one of our supplied demos to um, use one of our supplied demos. Adapt one of the existing demos to remove everything you don't want, and then make that existing demo into what you want, and then start your project from there. But look, sometimes it's not possible because we need to. Sometimes it's not possible because you already have a project that's been going on. Maybe it's a multi-year project that's been going on for quite a while, and I just need to move it to some sort of artist because of a new requirement. So I'm going to look at just how to create or adapt one of the projects that's existing. So okay, so the first instruction we have here is using your chosen tool, using your chosen tool. I forgot English today. Using your chosen tool chain. Using your chosen tool chain, create a new project that does not yet include any FreeRTOS source files. Perfect. We have a project here. This is my normal experimental project where I do all of my experiments. Here it is. Cool. So here's this project. Here it is. So you want to see it, you can go look at it. This is the one with the broken I2C non-blocking driver. Okay. So this is a normal project, CMake project for STM32F407. It does some LED blinky stuff. It does some I2C stuff. It goes and reads from a sensor and comes back. This is not at all a FreeRTOS project at the moment. But what I want to do is, for example's sake, I want to add FreeRTOS to this project, and most likely going forwards, do use it, do use uh, FreeRTOS with it. Okay, so let me see. 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 Okay, so we need to make let's make a file here, new folder, free RTOS. Okay, and then in that folder, I'm just going to follow the documentation, and I can. The point of this blogs is how it's done in real life. So this is what I do. This is how I do it every time. So I'll make a free RTOS folder, and then ensure the project builds. My project does build. Yeah, let's see. Yes. Uh, I've actually never built my project just building it. I always either run it or I don't have a problem running it. It's fine. Just sometimes it starts the ST-Link server and that runs forever and that uses so much memory. Meh. Run without debugging. Okay, run. Start debugging. Mm-hmm. Yeah, I think that works actually. Text debug. Let's run it. Yep, that runs. Cool. That runs. Uh, what am I trying to show here? What am I trying to show here? What I'm trying to show here is that our code builds all the way. Our code builds all the way and it builds without an issue. Okay, cool. That's all we need to see from today. Nothing else. Cool. So our code builds and it builds without an issue. We've added a FreeRTOS folder to our code. So now let's see. Let's see what. Okay. Ensure your new project builds, downloads your target hardware, and executes. It does do that. Only when you're sure you're ready to have a working project, add the free RTOS source files detailed in table 1 into the project. Okay, so copy the header files used by the demo project. Yes, let's do that. No, I don't want to be here. I want to be in FreeRTOS. I want to go demo. I want to go Cortex M4F, STM32. It's right in front of me somewhere. I know. STM32F407. There you go. 47. Cool. I want this file. Down row. No, I don't even care for that. I just want to copy this file. Copy raw file. FreeRTOS config.h. Let's make that file in our sources. I think it says include. I have no problem putting it here. New file. FreeRTOS config.h. Okay, that's in my include. Okay, cool. So we have FreeRTOS and free and so we can remove this. Or we can just use our own project one because that's how we want to do things. Sorry, my CMake uses UUIDs. Okay, cool. So we have that. We have our own. Let's say to copy that. Okay, cool. I want to kind of run start debugging to see if everything is run start debugging. Why? Why does this do that? Run without debugging. Run without debugging. Why does it do that? Run, start debugging, open. What's wrong? There's absolutely nothing wrong. Do I have something? Do I have some sort of something that is using something that is using something that is using yeah something that is using no, I don't think anything should be using that. Nothing should be using the GDB. Okay. Okay, I'll just close VS Code. Sorry, this always happens at my demos. No, the demos don't work. It's amazing because if I just ran the code by myself, this would never happen. I always get these issues. I always get these issues when I try and run it. Look at what I'll do. I'll connect a different. Look at what I'll do. And this will just, I don't know how this fixes it, but I can tell you this will fix it. This will just run. I can tell you that. I don't know how it'll fix it, but it'll just run. What did I do? I just changed hardware. I used a different hardware. I used a different board, but that's inconsequential because using a different board should not make this one be affected. So I don't know what is affecting it, but we'll figure that out later. Cool. We've added the FreeRTOS configs. Let's now do the other things. Copy the FreeRTOS or treat header file by your demo file and provide it for the port in use into your new project directory. Cool. Add the following directories to the path of the project will search to locate header files. I'll add that later. I'll add that later. Wait. This is basically okay. We can do this fast. This basically wants me to modify my CMake list, or I can either modify that or modify my ST project CMake. This is the one I'll choose to modify. So I'll add set free FreeRTOS source dir. Okay, I see. CMake source dir, and then this is Kali, and then this is FreeRTOS source. Okay, cool. New folder. So what do we want to do? What do they want us to do? Oh, we want to do all those changes to let's add the files first, and then we can do the changes to the CMake. Okay, cool. Because it's a bit. Wait. Okay, cool. I can actually go here and look at what they're doing here. Okay, so sorry, I had to reply to some stuff. Okay, I have FreeRTOS already downloaded here. Yes, cool. And then we have a source, and then we have an include. Yes, so I want to copy this include. Copy, and I want to put it in source, FreeRTOS source. And I paste. So copy, and then I want to go to ST workspace, my workspace, target, F4D1, FreeRTOS source, paste, include. Okay, so my include is here. My includes are here. Cool. So the first thing I need to follow is copy my includes, and then I need to copy my source files. Okay, so let me copy my source files. Documents, embedded, FreeRTOS, there. Probably should open, find a window. Yeah, and then documents, ST workspace, my workspace, target, F41. So I have these two open here. Let's do it. So now we need to copy the source. Okay, so FreeRTOS source. So I need to copy command. I need to copy tasks. Command timers. I won't copy stream buffer yet. I'll just take queues, and then I'll take list. Do I need list? Okay. Event groups. Do I need event groups? Yeah. I won't copy croutine, cmake list. No. S-bomb. That's fine. I'll copy those. Control C. Copy them, and I want to copy this into my source folders. Yeah. Okay. It wants me to copy them here. FreeRTOS source doesn't include here. I want to paste 5 items. Okay, cool. And then the other thing I want to go is I want to copy portable. Let's make GCC RMCM4 port.c. Copy. Wait. Copy. Paste. Again, the other file I want to copy is heap.4. Memory management. Portable memmanage heap.4. Paste item. Okay, cool. So we have all these sources, FreeRTOS, and it's here, and it doesn't include all that. I think we have what we need. FreeRTOS config.a is there. All files we don't need. Okay, now let's go back and modify our CMake. Sorry, I'm just slow. I think like that. FreeRTOS is source. Cool. So we have a FreeRTOS as source. We've defined it, and then let's make one. Let's make a. I'll copy in. Okay. I'll take port. Let's see. Is that where I want it to be? Okay, so here I'll make new folder. GCC. And here I'll make new folder. ARM CM4F. Okay, put that in there. Okay, cool. And then in portable, do I need a new memmanage? Yes. New folder. Memmanage. and then in here in memmange I'll put that. Okay, so what do we have? We have a portable, there's a GCC MM4 there, memmange, that, cool. Include has everything we need there. Portable has what we need, event groups, event group, list, queue, timers, task. Okay, cool. So I have some notes here that I'm going to copy in. This includes a FreeRTOS kernel. So let's do here. Okay, include FreeRTOS kernel, cool. And then let's include FreeRTOS header. Just a moment. So let's include the headers from FreeRTOS. Include headers from FreeRTOS. Here you go. Portable RMCM4. I think there's a header in there. Portable RMCM4. Portable RMCM4. Copy. And I wanna copy that. Copy, and I want to find a file. You find a window. Documents. SD workspace. My workspace. Target. F4D1. FreeRTOS. Source. Where do I want you to be? I want you to be in portable GCC RMCM4 paste. Do I want that? Yes. Okay, so and then let's now modify our CMake a little bit more to add okay, so let's add here. Where is project name defined? Set project name, set project name. That's probably defined in GCC there. Oh, my mouse just died. Okay. Not a worry. So we have free kernel static, add free kernel static, so link, cool. I think this is already included. I think my includes already account for include. Project name, set includes. I think my includes already account for that. Okay, that's fine. Okay, cool. So run, start debugging. Ooh, yes. Okay, let's remove that. Just a moment. I will find this. This is it. Okay. Okay, run. Start debugging. Okay. So adding the libraries breaks my. So I will try and add the libraries. I made some notes earlier and now I messed up because I don't know why something is missing. I'm just now gonna debug this here and not stop until I'm done. Although I hate. Okay, let me see. There is yeah, I'm defining it here. Why is that not working? Can I do? And what if I do it in my CMake lists? Is that okay? Before adding executable. Is that okay? Can I do these two that are causing my code to break here before I add my executable? Perfect. That's wrong. Typical stuff that happens when you try and include a new library in your project. Let's see. Let's debug that. Okay. I had no idea that is how it worked. So we want to do this. See now, I'm also learning CMake. That does this also want to be called after? Can I add you here? Ah, perfect. I know exactly what's wrong. So it seems like I need to include my, okay. It seems like I need to include my I'll show you. I just need to do include directories, uh, CMake source dir inc. I mean CMake source dir. Yeah, inc. Oh, okay. Let's see now. Perfect. This is even better. I know what the problem is. We need to go to our FreeRTOS config.h, and then here, this is a problem. So how do I FreeRTOS add GCC to list of compilers? FreeRTOS config. It's just a really small thing I need to do. I know how. I need to go and look at a commercial project. It's still some of my code from last year. It's a very, it's just a spelling that I don't remember how to do. I could have added it there. Okay. Okay. So it's GNUC. Defined if def. So can I just go GNU GNUC? Let's see. Okay, that should, let's say, run. Start debugging. But there is an external system called clock. Okay, so um, there is an external system called clock. If I do that, what am I doing wrong? Is this my problem? I wonder. I want to do this, all of this in my CMix. Just a moment. This will be okay just now. And then I want to go here and get these two. Okay. Let's see. And it's still failing, isn't it? Let's see, make. This is wrong. This is not helping. Yeah, that is helping. Okay, cool. So I want to take all of this out, and I want to put it in my CMix. Okay, guys, I'm gonna stop so that I can come back when I have a mouse. It's been a year. It's been a few. It's been okay. Next, yes. Can I do all of this here? Okay. Can I just remove that, remove that? Okay. If I run and start debugging, what happens? Still does not support. Okay. Excuse me. Let me go fix my mouse.